Hi everyone. Today we will discuss about the 4 types of nomenclature in organic chemistry. Let us take one structure like this, and this is a well-known structure, and how can we give the name for this compound? Now if we want to give the IUPAC name for this compound, because this is an ether, ethers can be represented as alkoxyalkanes. So this is the ethoxyethane, or commonly this compound is also known as diethyl ether. Now let us take another structure like this, and you can observe in this structure 4 oxygen atoms are present. Now what is the name of this compound? Because it is not a simple ether and it is having so many alkoxy groups, it cannot be simply represented as alkoxyalkane. So here we have to use some special nomenclature in order to give the name for this type of compounds. So today in this video we will see the different types of nomenclature in the organic chemistry which can be used at the different situations in order to give the name for the organic compounds. Types of nomenclature. Even we have the different types of nomenclature, mainly we can classify into 4 types. The first one is the substitutive nomenclature, and second one is the replacement nomenclature. Third one is the functional group nomenclature, or sometimes it's also called as radicofunctional nomenclature. And fourth one is the conjunctive nomenclature. So different types of nomenclature can be used at the different situations, and we will go one by one and we will see what is the nomenclature and in which condition they can be used. And here the substitutive nomenclature is more important because many of the compounds are named by this type of nomenclature, and particularly IUPAC uses the substitutive nomenclature. Even at few of the compounds, IUPAC can use the trivial names as well as other types of nomenclature, but the main nomenclature used by the IUPAC is the substitutive nomenclature. So let us start our discussion with this nomenclature. So first one is the substitutive nomenclature. Suppose if you take a compound like this, now in this structure if we count the number of carbons, this is 1, 2, 3 and 4. Now this structure is having the 4 number of carbons, and now we can compare this structure with the 4-membered hydrocarbon. So this 4-membered hydrocarbon, that is alkane, is commonly known as butane. So now we can consider the given compound as a derivative of the butane, where the given structure is having a functional group aldehyde. So here we have to replace the E of the butane with a suffix -al so that the compound name becomes butanol. So now this compound is a butanol derivative having the side chains which are indicated by the prefixes. So substitutive nomenclature uses suffixes as well as the prefixes in order to give the name for the given compound. Now let us see how we can give the name for this compound by using the substitutive nomenclature. As we have already discussed, the substitutive nomenclature is used by the IUPAC. So we have to follow the IUPAC rules in order to write the name for the given compound by using the substitutive nomenclature. So what are the different steps? In our previous video already we have discussed the 14 types of IUPAC rules and how we can give the naming for the organic compounds. So here just let us see the example for this structure and how we can give the IUPAC name for this compound. So step 1 is the identify the principal functional group. So here the principal functional group is the aldehyde. Since it is an aldehyde, we have to use the suffix -al, al. And second step is to selection of the longest chain. So here only one longest chain is there. We can count here 1, 2, 3, 4. It's a 4-carbon principal chain. Because it's having the 4 carbons, we can select the root name as the but. And since it is saturated, there is no unsaturation in this chain. So we can add the another term ane. But here in the ane, the E is replaced by the main suffix -al. And step 3, identify the side chains. So at the 4th position we can identify one of the side chain which is the amino. So we can write 4-amino. And 3rd position we can observe another side chain which is the chlorine. So 3-chloro. Now by combining all these, the name of this compound is the 4-amino 3-chlorobutanol. So in this way, in the substitutive nomenclature we can use the prefixes as well as the suffixes. Prefixes are used to indicate the side chains and suffixes are used to indicate the principal functional group. And by following the IUPAC rules, we can write the name for the organic compounds in the substitutive nomenclature. Now let us go with the second type of nomenclature, replacement nomenclature. In order to understand this nomenclature, let us start with the simple compounds. Now let us take a compound which is having the two oxygens within the chain. So how can we give the name for this compound? So first of all, let us see how we can give the name for this compound by using the substitutive nomenclature. So when we use the substitutive nomenclature, we have to identify the principal functional group, but here the principal functional group is the ether. So ethers are simply represented as alkoxy alkanes. So we have to select the longest chain which is attached with the alkoxy group. So let us give the numbering here 1, 2, and we should not give the numbering to the oxygen in substitutive nomenclature. So here this chain is having only 2 carbons, and similarly if you see this chain, again it is having the 2 carbons, and finally this chain is again having 2 carbons. Now which should be selected as the parent chain? Since the middle one is having the 2 side chains, it can be selected as the parent chain. So now the parent chain is having the 2 carbons, so it can be called as ethane derivative. Now this ethane is having the side chains which can be indicated by the prefixes alkoxy. So what are the side chains present? So this is the one of the side chain on one side, and this is the other side chain on the other side. So one of the side chain is attached to the first position and another side chain is attached at the second position. What is the name of this alkoxy group at the first position? So this is simply ethoxy group, and again at the second position we can observe the ethoxy group. We can combine these two as diethoxy. So now the name of this compound is 1,2-diethoxyethane. You can see that we can write the name of the compound simply by using the substitutive nomenclature. So 1,2-diethoxyethane. And this is the substitutive nomenclature as well as the IUPAC name of the given compound. Now here, since the structure is having the only 2 oxygen atoms, we can write the substitutive nomenclature in an easy way. So there is no need of replacement nomenclature. Now let us go with the another structure having 3 oxygen atoms. And again let us try to give the name for this compound by using the substitutive nomenclature. So we have to again find the longest chain. So this is 1, and again this is 1, and this is 1, 2, and again this is 1, 2. So the longest chain is having the 2 carbons, and again the middle one can be selected because it is attached to the 2 side chains. So this is again the ethane derivative, and one of the side chain is like this. So this is the ethoxy, and the second side chain is like this, but this side chain is having the 2 oxygen atoms. So we can indicate this side chain by writing the name from the terminal. So from the terminal we can consider this as a methoxy. This methoxy group is again attached to the another methoxy. So this is nothing but the methoxy. So in this way, to this ethane, 2 side chains are present at the first position as well as the second position. And when we are going to write the name for this compound, we have to arrange them in the alphabetical order. Ethoxy is going to start with the letter E, but methoxy is starting with the letter M. So which should be given preference? Ethoxy should be given preference. But in the numbering of this chain, we have given the second number to the ethoxy, which is not correct. So we have to interchange these two. So this is the first position and this is the second position. Now this is correct. So this compound is having the 1-ethoxy and second position 2-methoxy. So the complete name of this compound is 1-ethoxy 2-methoxy-ethane. You can observe that now the naming is somewhat complex, but still it is accepted by the IUPAC, and we can use the substitutive nomenclature here, and there is no need of replacement nomenclature. Now let us go with the another structure. How can we give the name for this compound? If we try the substitutive nomenclature, so we have to select the longest chain. So here you can observe this is the longest chain 1, 2, 3, and remaining are having either 2 carbons or 1 carbon. So this is the longest chain, so it can be represented as propane. Now this propane is attached to a long side chain, and we have to give the name for this side chain. So this entire side chain is attached to the first position, so we have to represent it by 1, and we have to start the name for this side chain from the terminal. So terminal is ethoxy, so we can write 1-ethoxy. This ethoxy group is further attached to the another ethoxy, then it is attached to the methoxy, and finally it is again attached to the ethoxy. So now the name is 1-ethoxy-ethoxy-methoxy-ethoxy-propane. Now it is more complex. That's why this type of nomenclature is not recommended by the IUPAC when this compound is having the 4 oxygen atoms. So here we have to use the replacement nomenclature, which is somewhat easy compared with the substitutive nomenclature. So let us give the name for this compound by using the replacement nomenclature. In the replacement nomenclature, we have to consider all the heteroatoms like the oxygen, sulfur, phosphorus. All these groups should be considered as the carbons. We have to give the numbering to the chain including oxygens. So this is 1, 2, 3. Then we are giving the numbering to the oxygen because we are considering it as carbon. So 4, 5, 6 and again 7, 8, again 9, 10, 11, 12, 13, 14. In this way, this compound is considered such that all the oxygens are replaced by carbon. So this is a tetradecane because it's having the 14 carbons. 14 carbons can be indicated by tetradecane. Now we have to see here, this is not the tetradecane, but it is having the oxygen at the different positions. So what are the positions where actually oxygen is present? So here the 4th position, 7th position, 9th position as well as the 12th position. All these 4 positions are going to be replaced with the carbon. So now the total of this sum is the 32. 4 plus 7 plus 9 plus 12, that is the 32. But again we have to check that the sum of the locands is minimum. So let us give the numbering in another direction. When we give the numbering in the other direction, we will get the sum of the locands as 3 plus 6 plus 8 plus 11, which gives the sum as 28. So this is correct and the sum which is 32 is not correct. We have to give the numbering in the second direction. So the first one is wrong. So it can be represented as 3, 6, 8, 11 and all the oxygens which are replacing the carbon can be represented as oxa. So 4 carbons are there, tetraoxa. So 3, 6, 8, 11 tetraoxa tetradecane. You can see that now the name is very simple. Tetraoxa tetradecane is simply indicating the what are this compound which is indicated by the locations 3, 6, 8, 11. So this is the use of the replacement nomenclature. Whenever the naming of the compound by using the substitutive nomenclature is more complex, then we can use the replacement nomenclature. So in this nomenclature, if carbon is replaced by oxygen, we have to indicate by oxa. Similarly, if carbon is replaced by sulfur, we have to indicate it by thia. And if carbon is replaced by phosphorus, then phospha. In this way, we have to use these prefixes. And nitrogen can also be indicated by aza, but for nitrogen, because it is considered as an amine, many of the times we use the substitutive nomenclature, but when the naming is more complex, then only we will use the replacement nomenclature. So replacement nomenclature is more common with the elements like the oxygen, sulfur, phosphorus, selenium. In this way, these type of elements use the replacement nomenclature. Now let us see the third type of nomenclature, functional group nomenclature, or it is also called as radicofunctional nomenclature. Suppose if we take the ether like this, what is the nature of this compound? This compound is basically ether, and this ether is attached with the 2 side chains. So these side chains can be represented as diethyl. So this is a diethyl ether. Now the name of this compound is ending with the functional group. So this type of nomenclature what we call functional group nomenclature. So this is the diethyl ether, and you can observe that when we're using the functional group nomenclature, the first word and second word is not continuous and there is a gap between these two. Diethyl is separate word and ether is separate word. So diethyl ether. So diethyl ether is the functional group nomenclature for this compound. And we can also write the name for this structure by using the IUPAC naming or substitutive nomenclature. In such case, we can call it as ethoxyethane. So ethoxyethane is the IUPAC name for this compound. Similarly, let us take another structure like this. So this is having the alcohol functional group. So we can consider as alcohol. This alcohol is attached to the ethyl. So this is a ethyl alcohol. Again, there is a gap between the term ethyl and alcohol. They are not continuous. So this is the ethyl alcohol, which is the functional group nomenclature. And by using the IUPAC, we can write it as ethanol. Similarly, if you take a structure like this structure is having the functional group as the ketone. So it can be represented as ketone. And this ketone is attached to the 2 cyclic ring systems. One is cyclohexyl, second is a cyclopentyl, which should be given preference. Because cyclohexyl is having the more ring size, it should be given preference. This should be considered as cyclohexyl ketone. So we have to write cyclohexyl. But this cyclohexyl is further attached with the cyclopentyl. So we can call cyclopentyl cyclohexyl ketone. So this is the functional group nomenclature for this compound. And if we write the name by substitutive nomenclature, here the ketone is present in the aliphatic chain having one carbon, so it should be considered as a methanone derivative. So the name of the compound can be written like this. So it is a methanone, and this methanone is attached with the two side chains. One is the cyclohexyl and second is the cyclopentyl. Both are having the same preference because they are considered as the side chains now. Then which comes first? Because cyclohexyl having the letter H but cyclopentyl is having the letter P, so H comes alphabetically first, so we have to write the cyclohexyl initially. So this is the cyclohexyl, cyclopentyl, methanone. Now you can see that here both functional group nomenclature as well as substitutive nomenclature looking similar with a small difference. Similarly, here this compound is a cyanide, so we can write the name as cyanide. This cyanide is attached to the methyl group, so this is a methyl cyanide. But this compound can be considered in the substitutive nomenclature as a nitrile, so this is the acetonitrile. So acetonitrile is the substitutive nomenclature. Now let us the fourth type of nomenclature, conjunctive nomenclature. Conjunctive nomenclature is used when one ring system is attached with an aliphatic chain having the principal functional group. Let us take one structure like this. Now here it is having the naphthalene ring system. This is attached with an aliphatic side chain having the principal functional group carboxylic acid. And this nomenclature should be used when the principal functional group is present at the terminal of the aliphatic chain. So you can observe that here this carboxylic acid is present at the terminal, so we can use the conjunctive nomenclature. Now this structure can be considered as a combination of naphthalene ring as well as acetic acid. So it is made up of naphthalene and acetic acid. So by combining these we can get the name by conjunctive nomenclature. So name of this compound is naphthalene acetic acid. You can observe that there is no gap between these two words. It is continuously written, but when you split this name you will get the two words which can exist as the compounds. Naphthalene is one compound, acetic acid is another compound. When these are going to be combined, they can give another compound by using the conjunctive nomenclature. So naphthalene acetic acid is the name for this compound. Since the acetic acid is attached at the first position, there is no need to write the 1. Otherwise we can also write this as naphthalene 1 acetic acid. And if we try to write this name by substitutive nomenclature, then the name of this compound is naphthalene 1-yl acetic acid. Here yl indicates we are going to use a substitutive nomenclature. So naphthalene 1-yl acetic acid, that is the substitutive nomenclature, and you can see the naming by both of these nomenclatures is somewhat similar. Now let us take another example. So here this structure is having the OH group as the principal functional group which is present at the terminal. Now this structure can be considered as a combination of cyclopentane plus ethanol. So this is the cyclopentane ethanol. And you should not consider the methyl group because methyl group is present as a side chain. It is not present as the continuous chain. So here the methyl group is considered as a side chain which should be again represented in the name. In order to represent this side chain, we can indicate the alpha and beta positions to the principal functional group. So this is the alpha carbon and this is the beta carbon. At the beta position, we can observe a methyl group. So this is the beta methyl. So complete name of this compound by using the conjunctive nomenclature is the beta methyl cyclopentane ethanol. Now let us write this name by substitutive nomenclature. When we are going to use the substitutive nomenclature, we have to identify the principal functional group present in the longest chain. So here the longest chain is the 3 carbon. So this is the propanol. Now this propanol is having a side chain at the second position, that is a cyclopentyl. So 2 cyclopentyl propanol. That is the substitutive nomenclature. So here the substitutive nomenclature is somewhat simple, but sometimes we can use the conjunctive nomenclature if we are going to focus mainly on the cyclopentane attached with the ethanol. In this way, we can write the name for organic compounds in many ways, and among these the 4 important nomenclatures are the substitutive nomenclature, replacement nomenclature, functional group nomenclature, and conjunctive nomenclature. And according to the situation, we have to use the one type of nomenclature, but for most of the compounds we will use the substitutive nomenclature. So that's for today. If you like this video, please subscribe to our channel and post your comments in the comment box. And don't forget to share this video with your friends. Thank you for watching this video.